when you are doing a two-column proof, I need you to split the page in half. On the left-hand side, we're going to do something that's called, we're going to put all the statements on this side. The right side has all the reasons. And all the reasons that I was talking about, they're found on page 8 in this packet. Those are all the if and then statements we just went over. What I want you to do is you're going to number your statements and number your reasons. All right, the one on the left corresponds to the one on the right. The first step is always to list the given. The given information is right here. So instead of rewriting it, we're just going to put ... and put given. All right, and we're just going to assume that we know this information. So what happens? Now that you've set up your proof, you look at your given and you mark the diagram with what you know. B is the midpoint of AC. What does that mean? Well, B is right here, AC is right here. I know that this part and this part is congruent, right? So since I made those tick marks and since that was my conclusion, I'm actually going to write it down as one of my statements. AB is congruent to BC. Now, who can tell me, or what would be the reason, since we're using midpoint, what's the if-then statement we're going to put down? Correct. That's why we made a big deal about this before. If midpoint, then segments congruent. We were able to make that conclusion because of the definition of midpoint. The second part of the given actually has C as the midpoint of BD. So now based on this, what could I say? That BC is the same as CD. I'm actually going to add it to the same step. BC is congruent to CD. And it's also, if midpoint, then segments congruent. Step 3. Now, let's take a look at what we have to prove. Somehow, I want to show that all of AC is congruent to all of BD. Now, are you able to say that it is congruent? In fact, what can you tell me about AB, BC, and CD? Do you think that they're all congruent? Right? And what's the property that allows us to say that? Transitive, exactly, because look what happens. AB is the same as BC. BC is the same as CD. What's the conclusion we could make about those two? AB is congruent to CD by the transitive property. Step 4. Somehow, well, we're not done yet, because now, how do I introduce AC into the proof? How do I introduce BD into this proof? What is AC made out of? A, B, and BC. So we're going to use segment addition postulate like this. AC equals AB plus BC. And also, I'm going to do the same thing for BD. BD equals, what does BD is made out of? BC plus CD. And the reasoning for writing this down is we're simply doing the segment addition postulate. Now, since all three of these are equal to itself and we're adding the same segments, what can be your conclusion about AC and BD? Would they be congruent too, since you're adding congruent parts? By substitution, they would be. So step 5 will be to say AC is equal to BD, and we knew that because we've been adding congruent parts. And step 5 would be substitution. The last step is the one about the measures and the congruent. Now, since here I have equal, whenever you do segment addition postulate, You're only doing the equal sign because you're adding the lengths. But now, well, technically we are done. This is a little typo. Let's add congruent here. I actually want us to show that they're congruent. So in here, to go from equal to AC being congruent to BD, we need to say if measures are equal, then segments congruent. And as soon as you find yourself getting to the point where the last statement you have in your proof matches to what you're being asked to prove, that means you're finished with your proof. My college professor would always make a little box, fill it in, color it in, because that would mean you are done with this proof.